Hello, everyone. So we were already introduced, but just to make sure, this is Magda and I'm Janek. And we are data scientists at Grupa Pracuj, where we are part of the big data team. And for those of you who don't know, Grupa Pracuj comprises several companies that all provide products and services in the HR space, particularly recruiting. Most of my and Magda's team's work is around Pracuj.pl, which is the largest job board in Poland. But before we actually start, some of you might ask, I'm a data scientist. Why would I even care about this Agile stuff? I'm not a product developer or Agile coach. And I guess that's fair. But before I proceed, I would nevertheless provide 3 reasons why I think you should take this seriously. So first of all, you might not be a product owner right now, but you well might be in the future. So obviously, you've heard 1,000 times how machine learning is taking over and so on. And there will be need of people who will manage those projects. And data savvy people at that. So you might well find yourself filling that role at some time. Even if you do plan to stay a data scientist forever, it might be still useful to actually learn how to communicate with product owners, to learn how they think and what are their concerns, so that you can firstly cooperate better, but secondly be able to actually propose your own solutions. And especially in large organizations, that will go a long way in establishing credibility of your team. And lastly, even if you want to be a data scientist forever, and I don't know, you live in a basement and your only data science product is a cat food recommender for your lovely mittens, well, I guess we still provide some useful advice to make that cat food the best cat food that he will get ever, because he's worth it. So what do we actually do in practice? So as I said, most of our work is around the Pracuj.pl website. So obviously, we have recommender systems. We have a search engine. We do anomaly detection. But on top of that, we try to analyze and predict user behavior. We forecast sales. And we create decision support systems. So I guess there's no lack of interesting problems. And we thought it might be fun to present our Agile approach on a concrete case that we do at our work. So this is what Pracuj.pl looks like. Some of you might have seen it, actually. And there are like few things on every offer. There is a job title that implies a category. So for example, every programmer job offer will be in the programming category. And this one is actually from Warsaw. And it has a content as well. So to provide some business background for this problem, on Pracuj.pl, the way that we do business is that recruiters or companies post the job offers on the website, and we try to make sure that they get as many skilled applicants as possible, right? So obviously, just hearing that, it's kind of no surprise that knowing how many clicks there will be, clicks on the apply button, we will call them just clicks to shorten up a bit. So knowing how many of these you will have is very useful, because first of all, you have a client and he expects something. So if you know beforehand what he might actually expect, it goes a long way in building a stable relationship. Whereas if you don't know, then you might promise him something that you will not be able to deliver. And secondly, once you actually know what entices people to hit that apply button, you can try to suggest them some improvements, right? You can maybe move the text a little bit, maybe add a picture or two, or maybe you want to refresh the offer once a few days have passed. So all these things are things that we could suggest based on our data, and if they provide the employers with more clicks, then we get more business, basically. But model is not enough. I mean, just knowing what will happen does not bring you anything. You need to somehow extract the business value of that knowledge. And this usually goes through creating some sort of a product, some sort of a framework. It might be an API where someone can automatically, for example, check different types of offer, right? Different types of content to see how it works. Or maybe it can just be a web application for our customer care and sales teams where they can see how the offer will rank among its peers and make suggestions to the employers. And operationalizing such a project, creating a model, creating an application, is a difficult thing. And because of that, we'd like to share with you our three-stage process to developing products, data science products, in an agile way. And these will provide you meaningful milestones so that you know where you actually finished one step and you can go to the other one. And this way you can save lots of time and money. And the three steps are experiment, creating interface, and pushing to production. And on the surface, it might seem that it's basically the same as normal software engineering projects, right? You will also start with an experiment and roll out to production, blah, blah, blah. However, data science projects have their set of unique problems and challenges. So, for example, already starting with the first stage, the experiment, when you are when I was working as a web developer, usually what would happen is that my product owner would come and tell me, Jan, make this, make like something possible, make a use case possible for them. And I would do that, and then he would come with some feedback, and he would iterate back and forth until finally he was happy. With data science, it's not that simple. If I spend 1 month creating a model for you, and then you come back and tell me, you know what, maybe we should like change this output a little bit, then basically I've wasted a month of my time, and I have to start from scratch. Moreover, the experiment might not even be like possible to conduct. Consider this. A few years ago, Google promised that they will predict the number of calories just from looking at the photo of the meal. And unfortunately, they're still struggling. And not every company has the resources that Google has to keep working on the same experiment for 3 years. I for now know that my product owner would kill me if I did that. So once you know that your model is more or less capable of handling the problem, you try to develop an MVP. And at this step, it's what I said earlier about the knowing the business requirements. You have to pinpoint them exactly. You don't have like the wiggling room to kind of iterate and come up with 10 different models and 10 different apps. You have to first know what we will actually do and then create an MVP. And as for the last stage, pushing the production, well, here the challenges are mostly project specific. I'd say that usually this comes to data pipelining and integrating different data sources. But as I said, this is like this depends on the total like environment in which you create the app. So the way we'll proceed here is that Magda will go on the use case that I described earlier with you through all the stages and how it panned out in our case, and then we'll pick some and go to conclusions.
Okay, so we started to create our product from an experiment which was about to help us to see if users' behavior is predictable enough to get some useful results of our model. One of the most important things about creating good data science experiment is to establish the point in which the experiment will be found as successful. And this point should be in a moment when product owners' assumptions about the accuracy of the model are fulfilled. It is often very useful to simplify the problem. For example, well-known case about predicting user ratings from the reviews. Instead of guessing exact score, they try to predict if it will be better or not from median. And we followed similar pattern, and instead of predicting the whole possible spectrum of clicks on our offer, we tried to answer the question whether this particular offer will be below or above median of clicks of all historical offers. If you want to build and train useful model, you need well-prepared data. And this is very important to make sure that you have everything that you need and all secure endpoints at the beginning of creating the product, because it may take some time. For example, in our case, it took quite a while. We decided to build two separate models. One for the features of the offer, like region, categories, etc., and the other for the content of the offer. Our approach was intended to show us the usefulness of each element. We chose XGBoost for features of the offer at the beginning and simple neural network with LSTM for the content of the offer. As we realized later on, we probably should have started with XGBoost with bag of words instead of neural network, because results were similar and it took significantly less time to train. Both models achieved accuracy at about 80%, which was a satisfying result for our product owner, and we could continue work on this subject. We even tried to combine models in a simple way by voting classifier with soft rule. A soft voting rule means that we average probabilities of all models and check whether the result was above 50%. Since we had only two models and probabilities for neural network were rather extreme, it usually overweighted the other model. And even though there was a very low correlation between probabilities of models, it didn't give us any good result. After we achieved promising results from our experimental phase, we could proceed to creating product which would answer business needs. And first thing that we had to do was to clarify business needs about the target of the model. Estimating with respect only to the median was too general for our business, and we settled on quartiles. Moreover, we calculated quartiles not for all offers anymore, but separately for all combinations of regions and categories of offers. Then we could start to work on our minimum viable product for internal usage, and we've built a web application with Django for our customer care department. It is very important, and sometimes also difficult, to deliver data science work in an easy and understandable way for users who might have nothing in common with machine learning. And this challenge comes with many DevOps and front-end tasks, which is a great opportunity to cooperate with other teams in your company. So guess what? We did almost everything on our own. And probably this was the reason why it took us about a quarter instead of a month. While you are working in an agile environment, you are expected to deliver small parts of bigger tasks, one after another. But data science style of working differs a little bit. And after you settle the architecture of the model, you have some time while model is being trained, and you can use this time to do something else. And this is the main reason why we were able to develop model and build web application at the same time. In relation to Agile, to working in Agile environment, it is also very important to document all your work. I mean, write down the architecture of the model, the set of parameters that you have used, and the results of this model. And by this, you can avoid repeating your own work or work of your colleagues. At this moment, we had data in many different places, and we had really huge technology stack. But we decided not to address this at this moment because we prioritized development speed over integration. You have to remember also that something can go wrong, always can go wrong, and you may need to go back to the previous version of your model. And of course, versioning code with GitHub is extremely popular among engineers and data scientists. But if you are a data scientist, you may also need to go to the previous version of your data set. And this is one thing that we have learned during building this model. Right now, we have a server where we put our data sets in a folder, and we have simple bash script which saves these data sets with the date of modification of them. And at this moment, we are running tests with our users. And we are waiting for the next iteration of their feedback so that we would be able to implement changes and improve its business value. And after we finish this part, we will be able to move to the last part of creating our product, which is pushing to production. The moment you are going to transfer your product into production version is the best time to look after the quality of your code. Maintenance of code which is modularized and has unit tests to almost every function is much easier. But it is also important to separate training of your model from the application. In order to, of course, keep the code clean and transparent, but also to reduce costs. Very often, if you need to train the model, you need stronger hardware, but for a shorter period of time, whereas the application itself uses very low computing power, but it needs to be available all the time. What are possible challenges when you move your product to production version? For example, like in our case, you can have two databases, which requires completely different kind of connection and sometimes very expensive joining data. But there can also be difference between getting training data and inference data. The former is usually a batch job, which you can do once a week or once a month, whereas the latter needs to be done on demand. And these two types of requests put completely different strain on a database. One is high volume and low frequency, and the other is the opposite. And what are our plans for future with our product? We are about to integrate our internal databases with Google Cloud and invest in automation of training the model and substituting it into production.
Yes. So Magda just went through a couple of lessons that we've learned along our way, and I believe they are all very important. But just in case, it doesn't go down the generations as the most important PyData talk ever and is studied in school, we thought maybe summarizing would be a useful thing. So we came up with a few key insights that we think would be most useful for people to consider when they start their data science project and they want to do it in an agile way. So starting with data scientists, first of all, as Magda said, make sure you know what data you will use. Getting this data then can take a lot of time and be a serious bottleneck. If you start with that, then you make sure that you will get it when you need it. Second of all, document all your experiments. So when developing a model, you will usually try a variety of architectures and parameters. And oftentimes you will choose some model, but then have to come back a few months later. So documenting what data you used, what was the architecture, what were the parameters, and what were the conclusions goes a long way in not only preserving the knowledge and making sure you don't repeat yourself, but is also a useful tool in transferring knowledge among the data scientists. And thirdly, something that Magda also talked about was making sure that you know which data corresponded to which version of your application. So this kind of knowing where your data came from is called data provenance, and it will, again, save you time when you implement it, and you will be able to come back when something goes wrong. And in real life, things always go wrong. And moving to product owners, imagine there's not many of them, but just put yourself in their shoes. First of all, you need to know your goals. If you don't know what accuracy you're striving for and what level of the metric, then you risk, one, that your data scientists will keep playing with a data set for a year just because they like it. Or secondly, you might end up working 3 years on a problem that you're simply unable to solve with the data that you have. So this, knowing what you aim for, is something that can both save you time and money. Secondly, from experience, I know if you tell me to make a model, I will immediately think of going to the one that I most like or is most exciting. And usually it's also the more complex one. In reality, in business applications, usually you want to start low, check if linear regression works, check with SVMs, if SVMs work, check if gradient boosting works, and then maybe you can move to something harder. As a rule of thumb, if your data scientist tells you that he totally needs to implement this neural network to solve the problem, look them in the eye and ask, no, but do you really do? And thirdly, although Magda is certainly the best front-end developer in Grupa Pracuj, let's just go with this, you might sometimes need help from DevOps, from front-end developers, from machine learning engineers. Make sure that your team has access to them and that they can focus on the most important parts of their job. And that's basically everything. We might be preparing a more advanced version of this talk. So if you'd like to know something about optimizing the usage of CPU or data in practice, or some other topic related to Agile, please let us know. Also, we have business cards. We had to tell administration that business cards are very important. So don't make us look like fools and come get a few. And yeah, okay. That's it. Thank you.
Okay, before the first question. You can do a more advanced version of this talk on our meetup. Just let us know. We have a couple of meetup planned this year. So yeah, the question.
Hello, thank you for your presentation. My question is about more down-to-earth aspects of agile management. Could you please comment what are your experience with such things as daily scrums or daily meetups and stand-ups, daily stand-ups or backlogging in terms of less iterative job as developing data science projects?
Sure. So in our case, we're not doing daily stand-ups. When we did, they were very technical and they were not really useful for the product owner. So what we usually do is we have like our own meetings, only the three of us, data scientists, where we discuss our work. And we communicate, we invite the product owner or the Scrum Master if they're needed. And as for planning, yes, I'd say it's very challenging. We overestimate the amount of time that things will take or underestimate a lot of times. Usually it's underestimation because we're ambitious. I also think that Agile, like the down-to-earth side to Agile, is more challenging in data science, just because you never know what will be the next stage. But I still think it's useful because it kind of provides, first of all, it provides a framework where you can actually see where you are in relation to your goals. And second of all, it's a great way to keep your product owner in touch with what you're actually doing.
Okay, one more.
Hey, great talk. Sorry if I didn't catch that, but you said that you're working in Scrum on Agile, right? But it requires 2 weeks, for example, sprints. And you have to define what you will deliver after these 2 weeks. So the question is, how that definition is defined? How do you find what you're going to like, what's going to be done by this date? Like, for example, product owner wants, let's say, 90% of accuracy on something. And probably you cannot say that we'll have that accuracy in 2 weeks because it's not possible. You have to experiment, right? So what are the definitions of done, let's say, after the 2-week sprint?
Usually, in our case, we don't define by accuracies because, as you say, that would be silly, and we can't expect that our model will improve by this and that. More likely, we would, for example, say, in these 2 weeks, we will try to develop the model. For example, in our case, there were 2 models. There was a model based on the content of the offer, the words that are in there, and one based on the kind of like specification of the offer, what's the region and so on. So we would say, okay, these 2 weeks we're working on this model, and after that we come back to our product owner. We tell him what was the accuracy that we were able to do, and he makes a decision based on a few things. First of all, based on whether or not it actually meets his criteria, right? But second of all, he would usually ask us how much time would it take for our next step of improving the model. So for example, we would say, okay, we can spend some more time tuning parameters, or we can spend some more time developing different kinds of models or ensembles. So this I can already estimate, right? And that's what I would tell him.
Okay. I think we can leave the rest of the comments and questions to the after-talk discussions. So probably going to find Yannick and Magda somewhere here at lunch. Yeah, because everyone was running to lunch. Okay, so I don't want to keep you here. We're meeting at 3.